All right, let's just jump right into one of the biggest questions you can possibly ask. It sounds simple, right? How big is the universe? But I'm telling you, the answer, it's going to stretch your imagination to the absolute breaking point.
See, the thing is, the universe isn't just big. It's paradoxical. It's totally mind-bending. And to even start to get our heads around its scale, we have to tackle a cosmic mystery first.
So get this, our current best estimate for the diameter of the part of the universe we can see, the observable universe, is about 93 billion light years. Let that number sink in for a second. Light is the fastest thing there is, and even it would need 93 billion years to get from one side to the other. Wow.
Okay, but hold on a second. Right there, that's the problem. How is that even possible? If the universe is only 13.8 billion years old, shouldn't the absolute biggest it could be 13.8 billion light years across, right? Something doesn't add up. So let's dig in.
All right, so how do we even begin to solve this puzzle? Well, it all starts with trying to wrap our heads around some pretty wild physics that only really come into play at these insane cosmic distances.
Yeah, this right here is the core of it. On one side, you've got the age of the universe, which is the maximum time light has had to travel to us. And on the other, you've got this size that just seems impossible. The math just doesn't work. So what are we missing here?
The secret sauce, the key to this whole thing, is a concept called cosmological redshift. Think of it like this. Imagine you draw a squiggly wave on a rubber band. Now, what happens when you stretch that rubber band? The wave gets stretched out too, right? It gets longer. That's exactly what happens to light as it travels through space that's expanding. Its wavelength gets stretched out, making it look redder.
And that is the big aha moment. It's not that galaxies are, flying through space like little rockets away from us. Nope. The actual fabric of space itself is expanding, and it's carrying those galaxies along for the ride. The space between us and them is literally getting bigger every second.
Now, this idea is absolutely incredible, but it wasn't some overnight discovery. It took time. Our view of the universe, our cosmic horizon, has just been getting bigger and bigger over the last century as our tech and our understanding got better.
I mean, just look at this timeline. It shows you how radically our view of things has changed. 100 years ago, we thought our own galaxy was pretty much the whole shebang. Then, people like Edwin Hubble came along and just blew that idea wide open. Look at those jumps in scale. Every single one was thanks to a new discovery, like finding quasars or detecting the faint glow left over from the Big Bang.
Okay, so here it is, the final piece of the puzzle that makes it all click. That light from a galaxy way out at the edge, when it started its journey, that galaxy was actually much, much closer to us. But, and this is the key, over the 13.8 billion years that light was traveling to reach our telescopes, space itself kept expanding, pushing that galaxy farther and farther away. So by the time we see its ancient light, the galaxy itself is now way, way out there.
All right, so we've got a sense of the size of the box, right? But what's actually in it? I mean, how in the world do you even start counting all the galaxies in a universe that's 93 billion light years wide?
Believe it or not, it starts in a way that sounds totally backwards. You take an amazing telescope like Hubble or the James Webb Space Telescope, and you point it at a patch of sky that looks completely, utterly empty, just blackness. We're talking about a tiny slice of the sky, about the size of a single grain of sand held at arm's length.
In theory, the method they use is actually pretty elegant. You stare at that one little spot for a long time, for days, even weeks, soaking up every last photon of light you can. Then, you painstakingly count every single smudge and dot in that picture, because almost every single one of them is an entire galaxy. And then you do the math, and you scale that tiny sample up to cover the whole sky.
Of course, saying it is one thing, but doing it, that's a whole other story. It's incredibly challenging. For starters, some galaxies are just impossibly faint and far away. Then you've got this fuzzy line. Is that a small galaxy, or is it just a really big cluster of stars? Sometimes two galaxies look like they're merging, but they could just be lined up from our point of view. And every time we get a new, more powerful telescope, it sees even fainter things, and the count has to change all over again.
So, after all that incredibly hard work, all that staring into the void and counting, what's the number? What have astronomers come up with? You might want to sit down for this one. 2 trillion, with a T,
2 trillion galaxies. And listen to this, that's probably the minimum number. For a long time, the estimate was around 200 billion, but new data suggests it's at least 10 times bigger than that. Just wow.
That number is so big it's almost meaningless, so let's try to put it into perspective. If you started counting one galaxy per second, 1, 2, 3, and you never stopped, no breaks for food, no sleeping, it would still take you 62,000 years to finish. It's just a number our brains aren't built to handle.
And you know what's maybe even more wild? With all of our incredible technology, we can only really study about 10% of them. That means a full 90% of all the galaxies out there are basically complete mysteries, just waiting for us to figure out how to see them properly.
So, okay, when you're faced with a scale that is just completely incomprehensible, what does that mean for us? Where do we fit into this enormous cosmic picture?
Well, this idea of a cosmic address really helps put it in perspective. You start here, on Earth. Then you zoom out, you see the solar system. You pull back farther, and you see our sun is just one tiny star among billions in our Milky Way galaxy. But then you keep going, and you realize our galaxy is just one of a few dozen in what we call the local group. And that group is just a tiny piece of the Virgo supercluster, which, you get the idea. It's just a single thread in this vast cosmic web.
And if your mind isn't completely blown yet, here's one more comparison for you. Think about all the beaches on Earth, all the deserts, every single grain of sand on the entire planet. Well, there are more stars in our observable universe than all of those grains of sand, and it's not even close. Remember, that's 2 trillion galaxies, each with billions of stars of its own.
And that really leaves us with one final, kind of tantalizing question. If everything we know, all of our physics, all of our understanding of the cosmos, comes from studying just that tiny 10% we can see, what else is out there? What incredible discoveries, what fundamental truths about reality, maybe even about life itself, are still just waiting for us, hidden out there in the dark?